Now that you know how to take derivatives, we're going to look at applications of derivatives. So this video, we're going to look at one of the most simplest applications. And that's the fact that a derivative gives the instantaneous rate of change. So it gives how a function is changing at one moment. Okay, so before in algebra where you've done like distance equals rate times time, you've actually been using an average rate. You've had to assume that something is moving at exactly the same speed. But we know in real life, a lot of times things don't move at the same speed the whole time. So derivatives will allow us to account for that and find an instantaneous rate of change. So kind of one of the most common things is you'll be given a function that represents a position, and just traditionally that'll be called s of t. Okay, so t is time, and for a position, I'm not exactly sure why, but we normally use the name s. Okay, then the derivative, so s prime, gives the velocity. Okay, and the second derivative, so the derivative of the velocity, gives the acceleration. Okay, one other thing that we should point out here is that speed is the absolute value of the velocity. So speed, is how fast you're going. Here, things that you should know is when velocity is positive, is greater than 0, you're moving forward. At that speed. And when velocity is negative, you're moving backwards. Okay, and so if you took the absolute value of that, it would tell you how fast you're moving backwards. Okay, so let's look at a problem. It says at time t, the position of a body moving is s of t equals t cubed minus 6t squared plus 9t. Okay, so just from that, we can find the velocity. The velocity is going to be the derivative, so 3t squared minus 12t plus 9. And the acceleration, which the acceleration is how fast you're speeding up or slowing down. So if it's positive, you're speeding up, and if it's negative, you're slowing down. So this would be 6t minus 12. So part A says find the body's acceleration each time the velocity is 0. So first we need to find when is the velocity equal to 0. So we're going to set 3t squared minus 12t plus 9 equal to 0. First we can pull out a 3, and that'll give us t squared minus 4t plus 3. And that factors as t minus 3 and t minus 1. So if we set each of those equal to 0, velocity is equal to 0 at 1 second and at 3 seconds, or whatever time we're given here. So let's, just for the sake of this problem, let's assume that t, I know normally it should give it to you, but let's assume that t is in seconds and our position is in feet. Okay, so if we want to know the acceleration, we would, at these times, we would do a of 1, which is negative 6, and the unit here would be feet per second squared, and our acceleration at time 3 would be 6. So we're just plugging these values into our acceleration. Feet per second squared. Okay, part B asks us to find the body's speed. So speed, we're going to want the absolute value of the velocity each time the acceleration is 0. So we're going to set the acceleration equal to 0. We'd get t equals 2. So we want the speed at 2. So we'd find the velocity. So v of 2 would be 3 times 2 squared, which would be 4, minus 12 times 2 would be 24, plus 9. So negative 12 plus 9 would be negative 3. So the speed would be the absolute value of that 3 feet per second. Okay, part C asks when is the body moving forward and when is it moving backwards. So remember, forward means we want to know when is the velocity positive. And moving backwards, we want to know when is the velocity negative. So basically we need to solve when is, so our velocity was 3t squared minus 12t plus 9. We want to know when that's greater than 0 to find the positive. So if you remember back from pre-calc, you can make a sign diagram. And on here you're going to put where is the velocity 0, which we already solved in a previous problem, that it's 0, 1, and 3. Then we want to test points. We want to test something less than 1. So if we test, and really time, we start at 0. We're not going to go all the way to negative infinity. So from 0 to 1, if we put something, we can even pick 0, we see that it's positive. Now if we pick something between 1 and 3, if we plug 2 in, well, we've already found v of 2 up here, we know it's negative. And if we put something like something bigger than 3, something like 4 in, we'll get a positive value. So this means we're moving forward anywhere where we've just put a plus sign. So from 0 to 1 and from 3 to infinity. And we're moving backwards from 1 to 3. Okay, at 1 and 3, we're changing direction, so we don't count those in either of them. Okay, now D says find the total distance traveled by the body from 0 to 2. Now, here we have to think about what's happening, and we have to be careful. We can't just take how far it was at 2 and subtract how far it was at 0, because we're going forward for a little bit, right? From 0 to 1, we're going forward. Then we turn around and we start going backwards from 1 to 2. So if we just took this point and subtracted this point, we would get, just this much. Okay, think of that as if you started at your house and drove to a grocery store and then drove part way back to your house but stopped to get gas. If you took how far you were from home right there, it would be different than how far you total had driven, what your odometer would say you had driven. So we need to take how far we've driven from 0 to 1. And here, since we're talking about our position, we're going to take the position at 1 and subtract the position at 0. We're going to take the absolute value. Then we need to take how far we've gone from 1 to 2. So we're going to take the absolute value of s of 2 minus s of 1. So remember our original function, the position, is t cubed minus 6t squared, I think, plus 9t. So if you plug that into your calculator, or however you want to do it, s of 1 is 4, s of 0 is 0, and s of 2 is 2. So from this piece, we just get 4. Here we would have negative 2, and the absolute value would be 2. So here we've got a total of 6 feet. Okay, so the important part with this last part to remember is if you're just asked for total distance, you need to find on that interval where is it moving forward, where is it going backwards, and you have to take these absolute values on each piece of where it's moving either forward or backwards.